Hey everyone, welcome back to my video blog where I talk about Azure, data services, and a little bit of professional development. So today we are going to continue on part 3 of the modern data warehouse in Azure. Go back and watch part 2 if you hadn't had an opportunity yet, because this will make a lot more sense when we get there. Now I will say that the first minute of the video got a little screwed up, so I have to record this first part just to introduce it, and then we'll jump into the other part I recorded. So basically, where we left off in part 2 is that you now have your data in Azure. It's sitting in a data lake or a database, maybe SQL or something along those lines. So congratulations, right? That's part 2. Now we're going to move in, and I have to assume that you've set up your zones, whether it be in your data lake or your database, as you need them. You know, whether it be 3 zones, 4 zones, 5 zones, whatever. Go back to the second video if that makes no sense at all. But now that we've got the data into those zones, into that raw landing zone, and we're ready for aggregation, we're going to go ahead, do some of that cleansing, get it formatted, merge sources, and go from there, right? So the idea is that we are going to transition it through those zones using an ELT tool, to use a modern term. Basically pulling it from the raw zone to our staging zone, do that necessary transformation, and land it in our curated zone. From there, we will put it together in our star or snowflake schema and build that serving layer. And that'll be the fourth part of this series, where we look at those options, whether it be something like Synapse, or, you use Azure Analysis Services, or just regular old SQL Azure database, right? A lot of options there. So anyway, enjoy the video, and like, comment, all that great stuff. Thanks very much for watching. Take care. There are certainly a lot of data processing legacy tools out there for ETL and things like that. So, the Informatica, SSIS, Talend, whole bunch of partners work on tools around that space for moving your data from, your source to your destination, and doing any of the processing, transformation, aggregation, cleansing, all of that stuff throughout that process. And there are also some cloud native tools in Azure, which is really going to be more of the focus on this video, because my thought is, if you're using the legacy tools, great. If that's what you decide to continue to use, great. That's your choice. But you know that tool. And so unless you're looking for a newer version of that tool, which some are starting to trickle out a little bit for cloud-based options, you probably know its strengths and weaknesses, and you probably know what you want to use. So the focus of today's video is going to be primarily on Azure Data Factory and Databricks. And we'll sprinkle in a little bit of HDInsight, because it is a tool that's available, and maybe an option if you're more comfortable with Hadoop and your team is comfortable with Hadoop, but not frequently used, just because there is some complexity to it, and if the team isn't familiar with it, it's probably not the best option nowadays. So kicking things off, we'll talk about what would be my preferred orchestration and transformation tool, which is Azure Data Factory, with both the data flows and the in-preview data wrangling interface. Data flows is very similar to an SSIS interface, where you're moving data from source to destination. You're doing some transformations in between there. You might be doing some derived columns, or joins or splits, and those types of things. And it's a very much a graphical design interface, where you're linking boxes. We call them activities in data flows, and they're going into a pipeline in Data Factory, where you can orchestrate that pipeline to start and stop on command, do all kinds of triggering mechanisms for when the data moves, and those types of things. The way we break down the data flows element is really, you've got 4 sort of main categories. You've got inputs and outputs. So you think about things like doing data joins or splits and unions and lookups and those kinds of things, right? The next one would be a schema modifier, where you'll do your data aggregation. You may modify some data within that stream. You could create new columns on the fly, and then potentially like pivot operations and those kinds of things. Maybe flatten some JSON, right? So there's a lot of capability in there for messing with the schema of the data. The next would be your row modifiers. So if you have to filter the data or sort the data as you're going through because you don't want to return all results, or you need to sort them in a certain order for some downstream operation, you do that there. And then finally, your destination, right? So in big data terms, it'd be called the sink, and that terminology stayed with the product as well. Now, beyond the standard transforms that I just listed, you also have a significant amount of configuration you can do to handle data sets of various sizing and complexity with partition strategies, data inspection and sampling, and things like handling schema drift for upstream operations where something might have changed on the fly, right? So the Data Factory options are fairly significant with regard to those, and what's happening is under the covers, Data Factory is using a Spark engine, okay? Now, Spark was created by Apache some years ago, and it's an open source data processing tool. And so really what's happening is you're putting these activities on the screen in the development environment, and behind the scenes there's code in the background that is running the operations on those highly scalable Spark clusters. So now I have a lot of customers that come to me and say, hey, why would I change everything to Data Factory if I already use SSIS? And how does ADF compare to SSIS? So those are very, very common questions I get from customers. And so to answer the first question, it really depends on what the operations look like. If you are running the majority of your ETL on-prem already, and it's using on-prem sources so that you can do the transformation on the fly and then land the data into a finished zone, and you don't have to worry about other data sources impacting what that curated or finished zone looks like, then I say stick with that, right? Land your data into the data lake and then get ready for staging from there. I have no problem with that. It's more when you add in new elements, you need to pull data from other cloud sources, or things like other data sources, or SaaS providers, the Salesforces and those providers of the world, where you might need to aggregate some data from these third-party sources. And sometimes it just doesn't make sense to pull that data down into our on-prem environment and then push it back up into Azure, because that can slow operations down. You save a step by pulling it directly into a data lake, okay? Now, part two of that is really with regard to the maturity level of Data Factory. Now, Data Factory is a very mature product. There's some great capability there, but SSIS was created 15 years ago. It came out in SQL Server 2005, right? So obviously it's a much more mature product, and it has a tremendous ecosystem where partners have created a ton of third-party tools that work really well with it. I would say that, with regard to the base functionality, ADF is fairly comparable at this point. Now, you don't have as much extensibility yet. We expect that to come down the road. But there are some great opportunities there, and really stick with what you know until the situation calls for a different platform. Databricks is a stark alternative to Data Factory because it's an open source tool. It's a third party that creates it, although it's an Azure first party service. It really is just a completely different development environment. ADF is very much GUI driven. You have end-to-end development tools that allow you to visually inspect what's happening. whereas Databricks is a code environment. Now, it's a very powerful code environment and allows for a ton of coding options and different languages it supports, so natively it supports things like Scala and Java and Python and R and Spark SQL. And, there's a whole bunch of libraries you can load for it, right? So it gives you a ton of opportunity to use a lot of different languages. And if your development team is very accustomed to that type of development, then Databricks could be a great option for you. Some people say that the developing through GUI-based tools is somewhat lacking in experience or just not real ETL. And I don't really agree with that. I think it just comes down to what your development team is good at and what makes the most sense for your particular operation. If your team is comfortable with that type of code-based CLI where you are building these notebooks that will loop transactions, that's great, if that works well for you. Beyond that, you can step outside of Databricks itself by using things like Data Factory to orchestrate notebooks that you're running inside of Databricks. And the same goes for HDInsight, right? You can use those same types of operations within Data Factory to be able to do similar operations and trigger similar activities. So really, it comes down to what is your team very comfortable with. And so, I would take that into account before you make the decision as to which platform you'll use. Now, Databricks is a very scalable environment and has some great opportunity for throwing a ton of data at a very, very powerful compute engine. Databricks is really a wrapper on top of Spark. So about 75% of Databricks code is Spark code, and the rest is the workspace put on top and some of the visual elements of Databricks, and it's an optimized environment. They've actually changed the Hadoop file system to a Databricks file system specifically for them for some optimization techniques. And they've introduced some newer technologies like a Delta Lake, so you can guarantee ACID transactions now. So there's quite a bit of capability in there. And again, it really comes down to what works well for your environment. The third option, which is somewhat of a lesser option by comparison to the other two, I have far fewer conversations about this, but still a good option and still well supported within Microsoft, is HDInsight. Now, this is the Azure version of Hadoop, and it allows you to spin up Hadoop clusters, right? So things you're familiar with, Hive or LLAP or interactive query or Spark, Kafka. You've got all these different cluster types that you can spin up inside of an HDInsight environment inside of Azure, and you'll have a lot of the extensibility and capability and connectivity with the rest of the Azure tools, similar to that of ADF or Databricks. It's coming from the Hadoop landscape, and not as many of our customers are as well versed in Hadoop. So I don't see as many calls for it or requests for it, but it is a very viable option, and you can use the entire Hadoop ecosystem for all of those ETL type operations that you're familiar with. Depending on what the team needs with regard to things like DevOps and continuous integration, continuous development, there are different ways to accommodate that with each of the tools. So when we talk about things like development, testing, QA, or production environments, each of the tools has its strengths and weaknesses to be able to transition between those stages of the development lifecycle. And so, whether it be native integration for Data Factory with tools like GitHub and Azure DevOps for some of that automation and testing, Databricks has its own DevOps lifecycle as well as HDInsight. And depending on the tools you're using, you'll have to focus on which one works best. Could be a combination of ARM templates to deploy things and scripts and stuff like that. Or some could be more workflow driven and native tooling from DevOps or GitHub. So definitely something you want to keep in mind there. They all have their strengths and weaknesses. Again, my preferred is probably Data Factory because I believe it's more fully integrated within the Azure ecosystem. But you should probably check that out to make sure what works best for you. Now, on top of these, there are obviously other third-party offerings within the marketplace. Now, some of the aforementioned vendors have their own Azure offerings, in different formats. Very few have a true platform as a service offering, so you may have to spin up virtual machines or some kind of a virtual cluster to be able to support those tools. Again, it kind of depends on what you want to do. I don't want to go too deep on those because really we're looking at the modern data platform. We're looking at those first-party tools that we have available in Azure. If you're looking for something that you're comfortable with that may have a third-party option inside of Azure, check out the Azure Marketplace for some of those tools, and those might be a good solution for you as well. So that about wraps up what we're going to be doing in this third stage, right? So now we've moved our data through the 3 zones or 4 zones or however many zones you have. And next thing we're going to be doing is we're going to serve up that data. And we're going to look at things like Azure Analysis Services and Power BI data models. We're going to look at Synapse as a destination or other similar tools where we can start to build our star and snowflake schemas to be able to set those up, serve them up to our presentation layer, and then set ourselves up for our reporting. I really hope that this video was informative and you got a lot of good, useful information out of it. I will certainly put any of the technologies I discussed in the show notes below. If you have any questions, feel free to put them in the comments below. Really appreciate the likes and all of the subscribers that I've gotten recently. Really, really helps out. And really appreciate anything you can do to share out these videos and get those counts up. So thanks again. Have a great day, and thanks for watching. Bye.